We've started a new standard on similarity, and this video talks about similarity triangle theorems. Two triangles are similar if and only if the corresponding sides are in proportion and the corresponding angles are congruent. So the symbol for similarity is this symbol right here. There are three methods of proving triangles are similar. We have AA, which is angle, angle. We have side, 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 SS. And then we have SAS, which is side, angle, side. So let's look at them one by one. AA, or angle, angle theorem. If two angles of one triangle are congruent to two angles of another triangle, the triangles will be similar. So what that means is, take these two triangles. If angle A is congruent, this is what the symbol for congruent is congruent to angle D, and if angle B is congruent to angle E. Notice all the geometry symbols used here. You need to know these symbols. If we have two angles of one triangle congruent to two angles of another triangle, we know by triangle angle sum that the third angles would also be equal, because all the angles of a triangle, the interior angles have to add up to be 180. So that's why we only really need to show that two of the angles of one triangle are congruent to two other angles of another triangle. So therefore, then we can write our similarity statement. Then triangle ABC, and I'm going to use a similar symbol here, is similar to triangle. Now this is where it's important. We need to make sure we correspond everything that matches up. So the angle that corresponds with angle A is angle D, so that's going to go first. Then we have B, and the angle that corresponds with angle B is E, so E has to go next. And then we have C, so then F would correspond with angle C. So that would be our similarity statement, if we had to write that. Alright, let's move on to SSS theorem, or a side, side, side. If the three sets of corresponding sides of two triangles are in proportion, the triangles are similar. So we want to look at our corresponding sides. So if AB, it corresponds with side DE, if that is equal to AC, which corresponds to DF, which is equal to BC, which corresponds to EF. I'm not going to put line segments over top of those because it would make this too crowded, but notice that they are line segments. So if those proportions are all equal and the three sets of the corresponding sides are in proportion, then the triangles will be similar. So if this ends up being true, then we could say that triangle ABC, once again we're using our geometry symbols, is similar to triangle, well, AB corresponded with side DE. So since AB went first, DE will go, and then F. So that's how we would write that similarity statement. So let's look at side, angle, side, SAS theorem. If an angle of one triangle is congruent to the corresponding angle of another triangle, and the lengths of the sides, including these angles, are in proportion, the triangles are similar. So here, if we have angle A is congruent to angle D, and then we have two sets of corresponding sides that are in proportion. So AB corresponds with side DE. That needs to equal AC over DF. And notice that where our angle is, it's in between the two sides. So that's why it's called side angle side. The angle has to be in the middle of these two sides. So therefore we can write our similarity statement. Then triangle ABC is similar to triangle DEF. Once again, we want to make sure everything corresponds and relates. So once the triangles are similar, the corresponding sides of similar triangles are in proportion. So we can use this fact in order to solve problems when we know that we have similar triangles. We can use these facts when we are wanting to prove that two triangles are similar.